Alright, so the first thing we're going to do is start a new part. So whenever I'm designing like a gearbox like this, I like to lay it out in a sketch before actually making features and stuff and making multiple parts. So it's definitely way quicker if you can lay as much out in a sketch as possible. So we'll say like, so the center, the origin is going to be where the wheel is on the gearbox, and then we'll kind of work out from there. So we'll say this is the gear that is on the output shaft. So then we're going to have another gear that is going up against that gear, and we're going to have, and so to get like a reasonable gearbox speed, it's probably going to end up being a 2-speed gearbox. So we'll put another set of gears on there. So this is our output, this is our like intermediate, and then this will be like the motor. So like a typical CIM pinion is like 12 teeth and 20 dp. So we'll let this represent the pitch diameter. So 20 dp, 12 tooth 20 dp gear, the pitch diameter is going to be 12 divided by 20. And we'll say this is, let's just say like 60 teeth for now. We'll probably end up adjusting stuff. And maybe let's just do like, so I'm entering equations right into Solidworks, and let's put like, let's just say like 30. Okay, so we want to calculate the gear ratio. Let's just get that right from the start, and let's say we're also using a 4-inch wheel here. Okay. So I'm gonna go to the gear, the design calculator, and I'm gonna save a copy. Alright, so I'm gonna put this in this folder. Jeez. Okay, so our driven gear is, let's see. So we said this was the first one was a 12 tooth. This is 60. I'm gonna put these over here in the high gear. So this is like, this spreadsheet's designed so it can be used for like a dual speed gearbox, but you can use it for a single speed gearbox also, and just see like multiple ratios that would fit in it. So let's try to design it for like 14 feet per second. So here we're at like 13.59, which is pretty close to 14. And then let's say 14 is like the max speed we want out of this gearbox, but then we also want it to be able to be adjusted down to lower speeds. Okay, so we're kind of close. I'm just gonna, for consistency purposes. Okay. All right. Let's figure out how we're going to put. Or okay, we'll let this represent the. This is the diameter of the CIM motor. I want to make this gearbox as compact as possible, so I want the CIMs to actually be sort of like overlapping the wheel, kind of on the outside of the robot. So they're like, so this circle's representing the wheel, this is representing the CIM. So we do need to space this stuff out. So let's start by making that a 14 tooth gear. Let's make this one a little bit bigger too. Like changing these teeth is definitely changing the gear ratio. So we'll have to make sure we're still staying within reason. Okay, this one. Let's see what that does. So we changed to 14, 64, 24, 38, I think. That's right. Yep, so this is 14.08 feet per second, that's pretty nice. So let's put, so this is going to represent the bearing, so we'll use 1/2 inch hex shaft and 1/2 inch hex shaft bearings. So the flange diameter is 1.225. Okay, that's fine. So we just want to make sure that doesn't overlap with our motor. Oh, another thing that I should have done earlier, but I think it's good to do. So for the mesh of the gears, you can add like a tiny little bit of tolerance, so they're not gonna mesh too aggressively. Let's do 0.003 extra distance between the gears that are meshing. We're modifying this one, yeah. Okay, so I'm gonna add 3 thou to that, and so that made this circle 1.5 thou bigger on the radius, and so we're just gonna do that to all of them. Oops. That's not the right one. Okay. So everything's looking reasonable so far, but we're gonna have 3 motors per side. It's the same size. Let's say we want these to be the same distance apart, just mostly for aesthetics. Okay, so now we need to connect these other 2 motors into our gearbox. So we're for sure going to need the same size pinion. Okay. So if that's not nice. Okay, let's go like this. Jeez. That could kind of work. Let's see. So we want this gear is going to have to be at least as big as that one because we want a bearing to fit in the middle of here and not contact the CIM motors. Let's just make this equal to that. Well, maybe we can go a little bit smaller. 62 tooth gear. That works, just a little bit of clearance. Okay, but these motors are like inside of each other. This is kind of hard to get this sketch to behave because there's a lot of unconstrained stuff. Okay, so this is going to represent the top of our frame rail. So let's say we want this gearbox to be able to be the center gearbox of like an 1/8 inch center drop. So let's So this frame rail would be 2 by 1, so let's do 1 1/16. So we know this motor has to be above that. Let's constrain something.
You should see the thing they added to our stuff.
You're being recorded. Okay, let's make these motors a little less crazy looking. Okay, this is starting to look reasonable, actually. Alright, let's put in some of... So this gearbox will end up having 2 plates. One that the motor's mounted to and all these bearings and gears are mounted to, and then another that are where the other bearings for our shafts are going to go, and it's going to mount to the frame rail. So let's figure out where some of these like the spacers will go. Let's do... I'm just sort of sticking them somewhere for now. We'll do like 1/2-inch spacers. So these ones are going to be these bolts are going to go all the way through the frame rail, or one side of the frame rail. Let's do it this way. Seems reasonable. Okay, so these spacers, so these big gears are like on essentially they're outside of the plates of the gearbox, but they're like in towards the middle of the robot. I'll just leave those there for now. Okay. This is still kind of unconstrained. So let's think ahead a little bit. Let's say, so this gearbox could be used at like the end of the robot, since it's sort of up against one side of the wheel here. Let's see what happens. Let's try to make this wall vertical, because it looks like it almost wants to be vertical. So let's make this kind of a nice number. Let's go for 3/4. And we'll say the part of our plate, let's make this 2.5 diameter. Make these tangents, so this is going to sort of, yeah, so this motor's position is constrained now. Actually, they all are. What if that's not okay? It's looking pretty decent. Are people visualizing what's going on? Yeah, Tim? Yeah.
So, is it like that for the CD, like at the back of the robot, or is it like we can
Well, it depends where the heavy parts on the rest of the robot are. Like, the drivetrain gearboxes are just one part. Like, you could put the battery way at the front.
What are those small circles that are not considered enough?
So those are representing where the spacers would go between the gearbox plates.
So how'd you determine the position of that?
Just sort of sketching in places that look like it would be decent. Let's make these the same height, just seems like a good thing to do. Let's say we want, so this is a 1/2 inch spacer. Let's say we want a little bit of clearance around beside it on the edge of our plate. Then we just need to constrain I guess let's make these, we just need to sort of pick something to reference them on, so just do that. Okay, this is decent. Okay. I think we'll be happy with that. So this sketch is just like the layout of where the gears and the motors and stuff are going to be. So I'm not actually going to use this sketch to directly, I'm just going to sort of hang out here. So then we'll do another sketch, and this will be our motor plate, the bigger one that gets all the motors and everything mounted. Okay, so we'll do a lot of referencing to our layout sketch. This will come straight across. It already snapped tangent. Guess we can just straight up convert those. Oops. Okay. Ooh, this will be interesting. Okay. So let's say we want this to be symmetric, just so the bottom of the gearbox kind of looks symmetric. And then, okay. So we'll this kind of has defined the radius of this circle, but that looks fine. Okay, so that'll be the outline of our gearbox. So let's make all the holes in it also. So we're gonna have our bearings here. These are all gonna be 1 1/8. And the holes for our CIM motors up here. Jeez. So these are 0.75 plus a little bit of clearance. And then these, I think these will all be tap drills for 1032. Let's put in the holes for our motor mounting screws also. So these lines are just going to help me position those holes. These all equal to each other. This is 2 inch. these are 1032s. And 1032 clearance, number 7. Okay. So now, we sort of want to position these screws so they're not going to be covered by those gears in case it just makes it easier to switch the motors. Oh, another thing, okay. I didn't see this, but let's make this. Oops, that's not what I wanted. We're going to make the outline get that motor too, because it sticks up a little bit. It's probably not the fastest way to do that, but. And just trim away that. Okay, so I'm positioning these screws. We don't want them to be covered by these gears that are going to be outside. But we also want to sort of position them to where we kind of expect the lightning on our gears to be. So these gears, the pitch diameter is ending up slightly, it's less than the overall diameter of the gear. And it's less for 20 dp gears. The difference is roughly 50 thou on the radius. So we can just rough that in order to make sure that our screws are not going to be. And those are just the clearance holes for the screws. So the actual head, if we use like 1032 buttons, it's like about 0.36. That's a tiny bit close. So I'm sort of thinking that we'll want, like, once we lighten out this gearbox, we'll probably want like a webbing piece between those two. So I'm sort of trying to position that on there. I don't think there's much hope we're going to get this screw between these two gears. Let's just put this. Let's just put that vertical. This one, let's just put it somewhere. Seems reasonable. I don't want, so I don't want these, I kind of want these screws to end up close to these lines, because when we're lightening it out, it'll just make it a little nicer if they're not off randomly in the middle somewhere. And this, if they're here, they're also not going to be covered by this gear. There's not really too much hope for this one, so if the middle motor needs to be swapped out, we'll have to remove this gear, but it's okay. Just constrain this guy.
So we're going to remove the second motor here, because the screw is not going to fit in.
The screw will fit under the gear, it just won't be accessible. So to get that motor off, you'll have to take the gear off, which is okay. Oh. It's not the end of the world.
Alright, so it's just going to be harder in like the replacing the motor process.
Yeah.
But it's going to work.
Yeah, it'll still work. Okay. So I think we're ready to make this plate. I'm going to extrude it, and it'll be a 1/4 inch plate. There we go. Okay, let's make the next plate. Okay, so we're going to put both these plates in the same part and then split them out into separate parts, but if they're all driven off the same part, it's going to make it so we don't have to do as many assembly references and stuff. So I'm going to space it out a bit. I'm going to sketch on this plane. So this is gonna where our second plate's gonna be. And then, okay, yeah. So we'll hide this plate for starters, just so it's. So now we're just seeing our layout sketch, which will end up converting a bunch of entities from. Let's look at it all from this direction. So we're gonna have those gears here, or not gears, bearings. So this is bearing for 1/2 inch hex shaft. These bearings, okay, so I can already sort of tell that we're not going to be able to use the same bearings here because the motors are going to be going over this plate, and that's the outer diameter of the bearing, so there's not much space left there for actual material of the plate to hold the bearing. So let's make these guys, they're going to have to be smaller outer diameter bearings. So we'll go for like 1/2 inch, or like, I think we'll use like 3/8 Thunder Hex bearings or something. Sure, 7/8 OD. Okay. And then we want, like, our webbing material, we'll say we want it to be 3/16. So 7/8 plus, let's just dimension that directly. 3 divided by 16. And then I kind of want to don't do that, because if we change the whole of it, okay, I should have been able to do that math easily. 3/8 plus 7/8 is 1 1/4. It's going to be the same. So this plate needs to avoid this motor here. So we can't just do a straight tangent line between those two bearings. So we'll do that. That's a little bit of clearance. And then we can connect these. Nice. And then this plate is tying into our spacers. Whoops. Not that one. Okay. So I am gonna show the other plate, or maybe I'll show the sketch for it. So we'll get some things from here too. Yeah. That's all we needed. Keep clicking the wrong button instead of the escape button. Nope. One more line up here. Okay. And then our screws, so the screws are coming in from this side, and we're going to make them, these will be 1032 clearance holes. Sweet. Oh, one last thing. So we'll use the center bearing thing from the West Coast Products gearboxes. So those holes, I think this is 1 7/8. Okay, I guess we'll just do this. Construction line, oops, almost. Midpoint. These are also 1032 clearance. this one's ready to go. Quarter-inch plate. Okay, so these are our two plates, and we'll lighten them up and make them look awesome later. But before we do that, we want to be like completely sure that the plates are the shape we want, because that stuff's real. Like lightening them out is super tedious, and if you're changing them a bunch after you do that, it gets really annoying, because it's more sensitive to broken sketches and stuff. So we're just gonna save this as, let's do flipped mini sim gearbox plates, and this is gonna be our master part. So now, okay, so we don't want to put this straight in our assembly. So this is one part file, but it's actually kind of like two parts. So we're gonna do this thing in Solidworks where we can actually save bodies. Okay. So this is gonna be do flipped mini sim. Let's just do like, these aren't great names, but we'll, where did this go? Yeah. They're quarter-inch. The quarter-inch plates work pretty nice with the half-inch hex bearings, because they're 5/16 width, but then they have 1/16 of flange, so the part that actually fits in the plate is a quarter-inch. Yeah.
So we make the gears, or
We buy the gears, and so I like the 20 DP gears, the half-inch hex gears. You can get them from IndyMark or VexPro. VexPro has lots of nice aluminum ones. So that's probably what we'd do. And West Coast Products actually has some lightened half-inch hex gears too, for the bigger sizes, which are pretty nice.
You can import the CAD files for the gears.
Definitely, and you should do that.
That's what we're gonna do.
And yeah, so all the gears are.
Hex shaft.
Hex Shaft is, I don't know, I probably won't download Hex Shaft because it's super easy.
Oh.
But the gears, like, you don't want to be modeling that for sure. It's a waste of time.
I was wondering, like, are there specific sizes of gear we have to use, or do they make them there? Like, do they make the gears any size we need, and then they'll cut them out, or is it like there's a whole set size or something we have to use?
So there's a couple like set sizes of teeth, and then there's a bunch of different gears they sell in those pitches. So VexPro basically nowadays they sell gears like every even tooth number of gear up to a really high number, like 80 something teeth or something, maybe even higher. So you definitely want to be using gears that you know you can just buy though. Okay, so this is our little plate that we're naming here. Flipped mini sim plate 2. Okay. Let's do that. Okay, so that's really, so what I just did, so we saved out these two bodies into new parts. So they're gonna like, okay, so like, this is really cool because these parts are referencing the like master part I made. So these parts will be the actual parts that we'll use in our gearbox assembly. But if you go back and modify the master part, and these parts will actually update, which is super cool. So like if I were to, like, let's just do a quick modification. Okay, yeah, it's sort of just for demonstration purposes. So this is where I save the bodies. So if I move that up above where I save the bodies, and then we look at the plate, that's the little one. Now it has this. So it did update, which is super cool. So let's get rid of that because we don't want that. Okay, let's work on our assembly now. So new assembly, we'll start, just put these plates in. Let's get the other one too. Okay, jeez, why is that still there now? Just need to save that. There we go. Just had to rebuild. Okay, so we're going to, like, when you're putting parts in your assembly, don't just let the first part go somewhere random and be fixed. Actually, like, constrain stuff to your assembly plane, or assembly datum planes. So we'll do, alright, let's start with this. Yeah, we want that. We want this. The right plane. Let's put this on the right plane actually. So that plate's gonna sit up against our frame rail. Okay. So we know we want these two plates the same spacing relative to where they were in the master part, so we can just constrain these together. These are the datum planes for the parts. I'm pretty sure one thing isn't, is that everything? Okay. It looks like we're good actually. Okay, let's save this. Okay, so let's put some stuff in here. Let's get our motors. Okay, let's... So we're just mating our motors in our assembly. We want that. Okay, let's put the wires near the top. So we'll get these holes here. Then we want our other two motors. Okay, coincident to that, concentric to this. Let's get that. Another one. And we'll do this one. So our wires are mostly at the top. Sweet. Okay, let's get some bearings. I'm gonna use that copy with Nate's thing again. So these are our 3/8 inch Thunder Hex bearings. And then now we want our 1/2 inch bearings. Actually, let's wait to do those. Let's do the gears next. So, okay. What size? So we said we had this one 62, this one 64, I think. Gears. And we'll use these. We'll use the West Coast Products ones. Because they're nice and enlightened. Yes.
Have you been spraying like the distance between the plates?
Okay. So the distance between the plates was set in the master part, and then we just constrained, or we mated the datum planes of the plates together.
So the master part, did you just like add up the widths of the gears, or?
I sort of made an educated guess on what I think it would want to be, and then once we stick everything in there, we'll see how close we were and adjust as needed.
Right?
Yes, you can definitely adjust it.
Oh, so it's like a rough sketch and your idea of how far do you think it's gonna be apart, and then
Right.
and then we can adjust.
Yeah, because we didn't that's not something we're gonna lay out in our layout sketch because it's kind of in a different direction. Okay, our 64 tooth we said is here. This one's the 62. Sweet. And we'll just do that for now, make them. It's about where those are gonna go. They look like they're meshing correctly. They moved again, okay. Alright, let's get our second stage gears in, which we said 24 and 38. 24, 38. We'll get the steel. I like to put axes on these gears so they're easy to mate to stuff. Yeah.
How does you make the gears mesh together? So does it just do that for you?
No, it's like there are ways to make it do that, but I honestly don't usually bother making it look like they're meshing perfectly. Like you definitely want your center to center distance to be correct, but I don't really bother making my gears look like they're meshing or making my hex shaft holes line up all together on the same shaft and stuff like that.
As long as the distance is different, you still have to do.
Yeah, I mean the distance, like you're not going to be able to tell if the distance is exactly right by looking at how they're meshing. You're going to want to do the calculation to get the distance right.
So is the diameter measured from like the part of the teeth or kind of teeth?
So the pitch diameter is kind of like sort of through the middle of the teeth.
Oh, I meant the
overall diameter?
the overall diameter. Does it count teeth?
Yeah, it does.
Okay.
And
So then if it's 2 gears, it's 2 equal.
if there's 2 gears, the overall diameter is like intersecting each other, like a Venn diagram or something.
Okay.
But the pitch diameter is for like tangent, and that's what you use to space the gears.
So in the layout you created just a circle without any gear.
Yeah.
You
So
just made them tangent to each other.
so that's the pitch diameter,
That's
yeah.
the pitch- all right.
And the pitch diameter is calculated by the teeth divided by the diametrical pitch, which is 20 for these gears.
So the actual thing looked like a Venn diagram, like you said. Like
Yeah, like the outer like if you have like, we'll just do it for fun. So like the outer dimensions of these gears are going to, let's see if this works. So they're like intersecting, right?
Yeah.
But the pitch diameters, so this one is 64 divided by 20. This one is 62 divided by 20. I got that wrong. Okay. So these are basically tangent. The reason why they're not tangent is because we added that extra 3 thousandths to make them not too tight. So there it is. Okay, we don't want to keep that sketch. So we got these guys in, and since we double checked, that's clearing. That's good. Okay, so this is looking pretty nice. So there will be a shaft that goes through there and supports that. So I'm sort of trying to think ahead, like how are these shafts and gears and stuff gonna stay on and be captured? Yeah, John?
What you could do is you could tap into the end of the Thunder Hex and then put a bolt with a washer on the end to keep the gears on.
Yeah, so I think yeah, we'll do that for these gears, because that's easier for us than trying to use retaining rings or clips or something. But then, so that'll keep the gear from falling off, but the shaft also needs to be able to stay, to not like what keeps the shaft from like going out of the gearbox? So, okay, I think I know what I'm gonna do, but let's put in the other bearings now. And let's use, so I'm gonna use 1/2" Thunder Hex bearings actually, instead of the normal hex bearings. Yeah. Oh, okay, jeez. I'm gonna let's see. No, we don't actually want a bearing in that hole. Actually, I don't want that either. I want this to point the other way. Okay. Yeah, we'll go like that. And since we checked, they're not touching. We already knew that was going to happen because we made sure in our layout sketch. I keep doing that, but I like to do this actually. Copy with mates. Yes. It's a little bit faster. Okay. So these shafts. Just yet, because let's make sure that we have the spacing of these plates correct before we do the shafts, because that's going to be important for the shafts.
Patrick?
Yeah.
You know the bearings, the holes that you put the bearings in?
Uh-huh.
You put a little bit of space between the bearings and the holes, so, or is it just perfectly tangent? So it fits perfectly?
So I've just modeled them the exact size. You could do, like, as long as it's pretty close, like, it can't be too much undersized. If it's more than, like, half a thou undersized, they're going to be really hard to get in, and they actually, like, will get squeezed and won't work very well. But then you don't want them to be too loose either.
So what's the clearance you use on them?
So if you want it to just slide in easily, it'll be like maybe 1/1000th of an inch, but not be sloppy. But really, you're gonna have to dial it in with however you're manufacturing the parts. Okay, so this section here, so our frame rail is gonna go here. Our 2 sprockets for our West Coast drive chain are going to go there. So let's put those guys in. We'll use these Vex Pro 18-tooth sprockets. Yeah, let's mate these together. Let me do it this way. Oops, that's not the right button. Yeah, John.
Why not use a double tooth sprocket, like one that essentially is just one part but two sprockets?
Because I want to use 25 sprocket.
They just don't make them for 25.
Not that, I don't think Vexpro does.
If you were using number 35 chain, would you?
Yeah, probably. I think so. If it fits better, I would. Okay, so that's actually looking reasonable. Looks like we got that spacing on our plates pretty close. Let's put in these bottom bearings. We'll use Thunder Hex bearings again. Flip that. I want the flange on the other side. Okay, let's put in that West Coast Products this thing. Yes.
What is that part?
So this is like, it goes through the 2x1, and then you can put a bearing in here, and it holds this bearing nice and out close to the wheel.
Alright.
And it's like, it's a COTS part. So and we just want to use as many COTS parts as possible, or not as many as possible, but as few custom parts as possible, so that it's easier for us to make it. Okay, let's put in some spacers. Hardware spacers. Put in a 16th inch spacer in order to get these gears to line up, because the bearing flange is on the different sides. That's wonderful. Okay. It's hard to see it. I guess I could do this. Boom. There we go. Okay. And then what's our spacer situation here? I like how far these sprockets are from this plate, so that's nice. So what do we need in here? Like 1 1/4. Okay. So we'll get this 1 inch one and a 1/4 inch one. Yeah, they're not showing because they're cross section. Okay, I kind of like to mate this stuff back to some sort of fundamental-ish part of the assembly, so that, like, oh, that was weird. Okay. Cool. And then this gear, it's just going to be straight up on there. Okay, so this gear we're going to need some spacers to keep it in the correct spot. Looks like 7/8 inches of spacers. 7/8, so that's going to be 1/8 plus half plus a quarter. Lots of spacers.
What are the sprockets for?
The sprockets are gonna be what drive, so chains are gonna go on the sprockets, and then those are gonna go to the other two wheels of the drivetrain. And then the one of the wheel is gonna be driven by the shaft, straight up on the output shaft.
Yeah, I don't know if this is a big question or not,
Uh-huh.
but why do we have 3 sim motors?
They're mini sims, and it's like the hot thing to do now, is the 3 mini sims.
So if you have 3, is it like...
So normally you use 2 sim motors per side. So the sim motors the mini sims aren't as powerful as the sims, and 3 mini sims turns out to work pretty well.
So
The meta, David.
it just drives the wheels. We just need to drive the wheels.
What?
So the sim motors,
Uh-huh. So
they're just there to spin the wheels. Is that basically it, or they're other functions?
yeah, that's what they're doing, is they're making the drivetrain go.
So we need 2. We need 3 of those.
Yeah,
It's a mini sim.
Yeah, I mean, you don't need 3, but 3 turns out to work pretty well. Like 3 normal sim motors, kind of you're getting to the point of diminishing returns on your battery current draw.
Yeah.
It's debatable how helpful the third one is, but...
So what are you saying? Like when you did your gearing,
Uh-huh.
when you did the gearing calculations in the spreadsheet, those were included, right?
Okay, so we'll go off on a tangent a little bit on the spreadsheet. So the spreadsheet, so this is my own spreadsheet, which is designed, unlike the JVN calculator, it kind of takes into account the voltage drop on your battery, because you can't just keep adding motors and getting more and more powerful. Your battery pretty quickly becomes the limiting factor. When you stall a bunch of motors, the battery voltage drops, which makes the motors, like the more current you draw from the battery voltage drops, which makes the motors able to output less torque. So this spreadsheet just sort of linearly scales the output, the stall torque back based on the voltage. So in order to know how much the voltage is going to drop, you got to know the internal resistance of the battery, and the battery B can measure this. So we have like typically 17 milliohms. Anything greater than that, we won't use that battery in competition. Yeah.
Did you come up with the equation?
I mean, I'm leveraging off of like data that Vex has published. Okay, let's get back on track. We can go into the spreadsheet more later. Okay, so what are we working on here? Let's do...
Are we gonna get to the hex shaft?
Yeah, let's do the hex shaft. Alright, so I'm gonna unhide that bearing real quick. Here it is. Let's put a wheel in, just so we can see it clearing. Yay! Yeah, right, okay. I don't know. I like to kind of constrain things all back to the same part or feature of a part that I don't think is ever gonna leave. Okay, so we want from...
Just make adjustments easier, right?
It makes it so if you delete parts, you don't lose a bunch of mates and stuff. So we have like good clearance between our wheel and our motors, but we're overlapping so that this gearbox is really not very, very wide. Just what this gearbox is trying to be. Yeah. And I'm gonna, so from here, we'll do the easy shaft first. 4.263. I'm looking at it down here. We have a starter part for Hex Shaft. And let's save this as lifted mini CIM output shaft. Okay, I forgot how long to make this. Going from here to here. 4.27, let's do. Okay. Do this again. Oops. Okay. Let's fix that. Cool. And we'll put in our washers. Sweet. I'm just gonna do this. Yep. Okay. Uh-oh. That ended up wrong. There we go. Okay, yes. Okay, let's do our other shafts. So, we already need a bunch of spacers on this shaft. So I'm thinking of what's going to hold this shaft in. So we could, like, we got a bunch of spacers on it already to keep the gear in the right spot. And we're going to have a screw and a washer to hold this gear on. And then we're going to need, but there's nothing that's going to prevent, if it's a Thunder Hex shaft from it like sliding out in the direction towards the gear. So you could put another washer and bolt like on the back here. You'd want to make sure it clears the frame rail, which we don't have modeled right now. But I'm not gonna do that. I'm gonna start with a half inch hex shaft, then turn it down to Thunder Hex for this Thunder Hex bearing, and that sort of step is gonna keep the shaft captured. Okay, so let's first start by sketching a we're just gonna make it a number for starters. Where did it go? Part 5. We just save it as something. Put mini CIM. Intermediate shaft. And since I'm gonna just put an axis through this so it's easy to mate to stuff. And I kinda wanna mate it straight to this part. Okay. So how long does this shaft need to be? So that is 1/32 off of that plate. That's 2 inches. So 2 minus 1/32. This is, let's put a 1/4 inch spacer. And that's 1/2 inch gear, so. So 2.75 minus 1 divided by 32. Okay. And then, so, I'm actually going to edit it in context, or in the assembly, so we know we're putting the right things on the right side of the shaft. Edit that, let's also isolate it. 3/8 inch thunder hex, so 12.25 millimeter. No, that doesn't seem right. 10.25. I think that's it.
Isn't it just supposed to be 3/8 of an inch?
It could be if we used a 3/8 inch bearing, which we totally could have done. But I chose to use the 3/8 inch thunder hex bearing. So it's not. And then cut extrude, we're gonna flip that. So this is it's gonna be 0.25 minus 1 divided by 32 plus the flange, which is a 1/16. So that should be the right number. Okay, then this other side should be easier. Okay, so we're turning this into 1/2 inch thunder hex, which is going to be 13.75 millimeters. I'm gonna cut that. Okay, so this is 0.75 plus 1/4 plus 1/16. Let's see if we got that right. Where's that bearing? I think that's right.
Patrick,
Yeah.
how is that shaft gonna stay on there? Are we gonna tap the end and put a screw in there?
So we're gonna tap this end to hold the gear on.
Mm-hmm.
But then this other end is, so that's just what we just did. So this other end is going to be, there's these little tiny steps where it changes from hex to thunder hex. This is kind of like a trick that I think is underutilized, but it's nice because it saves us from having a screw over here, and also when you like take this, when you take that screw off and remove the gear, then the shaft is still like captured. And it's gonna be, so luckily we can use the same exact shaft on this guy too, and it prevents us from needing a bunch of spacers in the middle, which is quite nice.
That shaft, do we have to manufacture ourselves?
So we'll make it, yeah, we will, and we'll make it out of 1/2 inch hex shaft, and luckily the things we're doing to it are pretty easy to do on the lathe. Alright, one last thing the shaft needs though is a hole because the 1/2" hex shaft does not come with a hole in it like the. Okay, yeah, that's already right. Like the Thunder Hex does. Seems reasonable. Yes. Sweet. Okay, we have our shafts. So everything's seeming pretty reasonable, so at this point we could get to we could start pocketing out our plates. But we definitely want to like make sure we're pretty happy. Okay, like let's model in the frame rail a little bit just to make sure that we're not running into any issues before we start pocketing our plates. Yeah, that's not really what I wanted. Let's go right plane. So 2 inches tall. We said, we'll say this is like the center dropped gearbox by 1/16. I think this is 375. I think that's what the West Coast Products thing is. .32 clearance. .7/8. Okay. This is just an arbitrary number. And then our other holes were 1.75 from the center, I believe. 1032 clearance as well. Okay. Okay, yeah, I'll say that. 2x1. Yeah, we'll make this from the Vex Pro stuff, which is 10th inch wall. Sweet. Okay. Frame example. We'll just do that. And we need to prevent it from swinging around, so. Sweet. Okay, so we're clearing our motor. That thing looks fine. It looks like there is space between our, like, the chain, like, our belly pan could go fully underneath this, or like where the chain is gonna want to go, which is good. So it's looking pretty reasonable.
Patrick?
Yeah,
So the chain is gonna drive the other 2 wheels, right?
that's right.
So which way are the wheels gonna be placed behind?
Well, it's either, like, you either do 2 on this side,
Yeah.
because this gearbox, like, because you usually want the wheels, like, all the way out in the corners. Or this could be the middle wheel, and then you can do 1 on either side.
Yeah.
Yeah. Let's get those spacers in real quick. Hardware spacers, these are, is it 1/4 inch? so particular about mating to that plate. It's gonna be difficult. Oh no. Got it. Okay. Alright, we'll put those washers and stuff on later. Let's get to the fun part. Okay, so let's do these and we're gonna still modify these in the master gearbox part plate thing.
If we do it here, does it change for everything else?
Yep, it'll propagate through. Yes.
What about from the mini CIM like shafts onto the bigger gear?
So those do need gears. Like, you're saying it's missing the pinion gears?
So you think those on later?
Yeah, I'll put those on later. Like, I can already tell that they're not going to cause us any issues. Like, okay, we can put them on now. I'm like eager to get started on the, okay. The part that makes it look cool. Okay.
That's very tedious.
Okay. We'll...
Don't they need spacers?
We'll use those retaining ring things. Okay. It's gonna do it this way. Yay. Okay. So, those are meshing properly. Now I think it's definitely safe to start on our weight reduction stuff. Okay, so let's just hide this. We'll start with that guy. I don't know, I want to do it from this direction, but... Okay, so the first thing we'll do is offset the perimeter, and we said we're doing 3/16 inch. And then let's define where all our connecting things will be. So, well, okay, we'll save that one for later. It's good to start by like going through where the gears are actually like applying the force, so to speak, I guess. Let's just show that so we can snap to some stuff. So that's gonna go to there. This gear is connecting to that gear. That's going to there.
Click and drag.
Yeah. I know I can do that. Okay, there we go. Let's do this one too. We'll do one straight across here. We're gonna end up doing more. Let's do... Go up to here. This area is gonna get a little bit messy with all those things there. That's okay. Go like that. Put one here too. Let's do... Oops. Didn't get exactly what I wanted there. Okay. Okay, so we need a little bit of... Let's do like 1/2 inch for these things. We'll do 1/2 inch for those. We'll do bigger for these because these are going to be on 1/2 inch spacers.
So they're just to make sure like we have enough space.
Yeah. So we'll do 1/2 inch for all these motor mounting screws. Nah, that's not 1/2 inch. Okay, 5/8 for these guys. Okay. And then we want 3/16 around that hole, so that's like, I could dimension it directly, but the reason why I don't want to is because if I change the diameter of that hole by like 1/1000th of an inch in order to get the bearing to fit just right, I don't want this thing changing also, so this is 1.5. And then 0.75, jeez. Okay. 0.75 plus 3/8 is 1 1/8. Okay, I don't know why I did that. Equal. And we're, yeah, dimension only one of these. 1 1/4. No, 1 1/8. Here we go. Don't know why I didn't do these ones earlier because it's going to be the same as that one. Okay. Let's throw another one from here to here. Do one down here.
What are those lines for?
Those lines are showing where we're gonna leave material to connect all our bolts stuff together. Do one up that way, and let's do one more for here.
Why did we use like such a big amount for that little hole in the center?
Which hole?
Like that,
This
those
one?
4. How come they had to have like such a much larger amount?
Well, there's gonna be a 1/2 inch diameter spacer on those guys,
Oh, okay.
and
You want it like the 3/8 or whatever larger than that thing?
I'm having it like a 1/8 bigger, which will be like a 1/16 on the radius. And it just makes it so it's not looking like it's supposed to line up perfectly and not lining up.
But when you have the space on there, it'll look like 1/8 larger than it?
It'll, yeah,
Okay.
I don't know.
Okay.
You don't have to do that, but that's how I'm gonna do it. Okay, let's start drawing our lines here. That one snapped to the horizontal. We don't want that. So, symmetric, parallel. And then we want that distance to be same as that. This is our offset. That's 7/8. Oh, we don't want that tangent. No light gave me that. This part can take a while. There might be a faster way to do this also.
I was hoping you could tell us a faster way to do it. This is why this is the worst part.
This is why you don't want to, you don't want to start doing this before you're ready to.
Yeah.
Especially if the animate's so slow right now.
You don't want to end up having to redo it.
So if you need to make even the tiniest change, it can just mess up everything. It's just
Yes.
the most annoying thing to redo all of it because some little thing decided it didn't like it.
Look how it did that.
So Solidworks likes to make those tangents.
And I also would snap that one to vertical, which we don't want either.
Yeah. So many little annoying things. I guess we can just, we're gonna need that a lot. I just copy
copy pasted it. Purposely not making those horizontal in case we ever change this line off horizontal. I could just copy and paste that so I don't need to keep clicking on it.
One thing I've tried while doing this is offsetting all of the construction lines to both sides.
Yeah.
And making those lines for construction, because then I just have a ton of just basically guidelines, and I just have to match the points with a bunch of arcs.
That's interesting.
And that works pretty well. I think it's the best way I've found so far. Other than that, it's basically just making parallel and symmetric, and that is mentioned.
Yeah, I kind of don't want... We're going to end up with this weird thing over here.
Yeah.
Oh, jeez, I didn't want that to come to. And of course that was the one that I had dimensioned. Alright. Kind of gonna aim for sort of between this whole mess up here. And let's go. Alright, having some issues. 100. Kind of between that stuff. Oh, let's definitely put one right here too. That seems to make sense.
Make it go linear with your lines.
Go linear with that guy?
Yeah.
I want it perpendicular to this though.
They're close enough.
Okay. This is gonna be fun right over here. Okay. Deal with this area later. Jeez, that seems to keep happening. That definitely got something I didn't want it to. Dimension. Get both of these at the same time. Let's do some of these easy ones. No, I don't want tangents. Hopefully we can fit our radius on both of those. Definitely not going to bother in that there. Don't know why that line went black. Probably. I don't want that, I guess. Okay, so this situation we'll just straight up put our fillet in there. I have a hotkey for tangent because I use it a lot. Do an eighth maybe? Cool.
Wow.
Okay, let's figure out this situation. I think I'm
See if it fits between that circle and the closest one first.
make these parallel. I kind of don't like this huge chunk of material that's gonna end up here. Let's just make this collinear with that to reduce the great mess of material that's gonna end up there. And I think this is gonna be. Oops. I keep hitting F1 when I'm going for escape. Okay, so that actually got that right. I'm gonna save as much to put in feature fillets as possible. Okay, now we start trimming. Oh, it was on the midpoint. Okay, well, that's fine. It's still vertical. Oh, I clicked on the wrong thing. Okay, apparently this was not actually on there. Now it is. Got all that. Leave these guys. No. But I do have a big clump of material there, that's okay. Pull it right through. I think we're getting close. Is that it? Nope. Why is it? I feel like something's not quite done yet. There we go. We're going the other direction. That's a good point, though. It would have cut through the other part if it was going that way. Now we get to do this. Fillet thing. Like 100 something.
We fill it every.
Yeah, we got like 100 things to click on or something.
What's fun is if you just fillet the flat face of it.
Yeah.
So it looks the entire thing.
It does the
Not
edges you
proper,
don't
but
want
just
also.
the line. It looks amazing.
And we'll see if we run into any issues here. And when you're doing this fillet stuff, it's best to like complete it every once in a while to sort of save your progress and then
Oh,
to
yeah,
get
when
going
you miss
again.
One thing, everything just goes. That's a good idea.
Yeah,
Like that.
it's not what I wanted.
Looks pretty cool though.
Yeah.
So what about like kind of messy area in the middle where it looks like a B? Is there a way to clean that up a little bit, or?
We'll put fillets in there. It'll make it look a little cleaner, but it's... So see how there's like not enough room for the fillets there? So we'll not put those in just right now.
So let's see if you put something else in the center.
Of this little deal,
For the wood.
I kind of think it's not worth it.
I don't think it will make that much difference.
I just mean
From the
aesthetically,
wood.
it looks.
There we go. It'll like it'll look a little nicer once we. Okay, now I clicked on some things I didn't want. It's gonna look a little nicer. I'm wondering if they're gonna fit in here. Yep. I'm gonna save my progress on clicking on edges. Oops, not what I wanted. Fail. Oh my gosh. No.
Have you ever done like a 2-hour session of this as well for everything?
Yeah. I try to like save every time I'm like switching between parts or something. Sweet. I guess we could have put in the spacers in our assembly before we started this part of it. Alright, this may be tight down here. Oh, we're good.
What's the radius of the fillet?
1/8 inch. So it should be bigger than whatever bit you're going to use to machine it. Not the same size, but at least a little bit bigger.
If you are water jetting though, you can make it smaller potentially, right?
Oh yeah, you can make it a lot smaller if you're water jetting. A lot smaller than 1/8 inch. I kind of like to make it not too small though. I think it looks better if it's there a little bit.
Is a fillet to make it just cooler or no? Or just.
It's to make it manufacturable, because...
Oh yeah, because if this is too much of a sharp edge, you can't. Alright, yeah.
Yeah, okay, yeah, I forgot, we can't do that one.
So are we gonna make them just router?
We could make it with the router.
Faster with the water jet, right?
Yeah. We're definitely...
The water jet doesn't take into account like time to wait until it gets fabricated.
Right, that's true, because we don't have our own water jet, we have to get parts water jet.
Can the router do like 1/4?
Yeah. The router, I'm not sure what bit we're gonna prove to really like on it.
Yeah, I should make
Probably not. Should make some things that What happened here? I think we were supposed to have like a thing there. Apparently we just never did it. Still got that. Yep, and now it lost something. Hopefully that's it. Nope.
So we're not the one with the too small.
Okay. Did we miss anything? So we had an issue down here. So for those guys, like you could go add them in the actual sketch, or you can do this, like face fill it, and it will it can totally, it does exactly what you want it to do. Okay, that's looking pretty good.
How is the other one?
Yeah. Let's make this more, I don't know, I just did that. Let's make this more nice of a color. That's also harder to see, but I think that looks cooler. Okay, thankfully this one will be quicker because it's smaller. For now, we'll just look at it that way. It's easier to see. Okay, showing that real quick. Same process now. Let's connect. This will connect. Actually, let's not connect that. For sure one of these. Let's do this. Definitely just straight across that whole thing. I don't think we had this one in the other plate, but we did have, I think this is okay. Let's sort of aim in this general direction. Hit sort of in this area. I think we actually had that on the other plate, and I think that was 100 degrees, but let's actually reference that so it lines up just right. Okay. These guys are ivers. Oh, I did just notice one thing. These holes we actually want to not be clearance holes. We want them to be 1032 tap trail holes. Okay. Alright, back to what we were working on. I don't know why it wants to do that. Yeah, I see that. Yeah, we don't want that. Don't really want to use that from sketch 5. Let's go. I'm gonna make it equal to this. And we'll copy and paste that for future use. see if we can, what we can fit in there. Delete that one. I'm actually just gonna make these go all the way across.
They're parallel, right?
Yeah, well, they should be. Something's up here. Okay, clicked on the wrong stuff. Nope. Don't want that. Control Z. Yes, I should make one to the bottom. Yeah, I got the midpoint. That's why it asked me that. Okay. Here. Is that it?
I think that's it.
Sweet.
Those tap holes for the tender too.
Oh,
Yeah.
definitely don't want that. Looks pretty thin. Trim the wrong thing. Ooh, sometimes these are hard to click on. Jeez.
You should fast forward this part when you're in the video.
Yeah, probably. Count how many times I click on a face instead of an edge.
Which is drinking. That's actually appropriate.
Definitely, John. And let's see how this. Nope.
You gotta fill the two surfaces.
Yeah.
What's the downside of doing that?
Just in wait in the same corner.
Where?
Big circle to that one, center one to the one that's to the
There we go. Yeah, yeah, okay. Thank you.
What's the downside of filling two surfaces?
It's just another feature, I guess. Don't know.
Not really. There's not really downside
I
to
mean,
it.
if you kind of can only do one feature, or you can only do one fillet per feature, which would make it like a bunch of features if you did it for all of them. That looks pretty nice. Rebuild.
You can save it.
What? Didn't I save? Oh, I think I know what happens. Where I need to go back to my master part. And I probably need to, yep, I need to move the save bodies below all that other stuff. There we go. That's looking pretty sweet. And let's put in our spacers, which I think
Is that it? After you put the spacers in?
no, but it's just other little stuff. Yeah, I got the right ones already.
What's the distance between the two?
Let's do inch and a half. One more spacer. It's pretty close to that motor, but it should be good. So we check that. Just double check. Cool. Okay, let's put in those washers. We already put it down here. It's not going to be that much room for a screw head there. We should be able to do the copy with mates thing. Yep.
Those are gonna get tapped, right?
Yep. Well, you could make your own, but we'd probably be lazy and just order them from McMastercard to this.
From whatever distance you want.
Yeah, like in like 1/8 inch increments.
They come in 16th inch
16th.
increments below 1 inch.
After 1 inch to 8 inch.
Yeah.
Let's use these. We'll use those screws to. No, actually, I don't want those screws. Let's use.
More surface area though.
Yeah, but they're like more uncommon. And we have a washer. It's a nice washer.
I mean, but you can just use the other screw with the built-in washer and not even use it.
The built-in washer is like barely enough. I like to use a real
Okay.
washer.
anything there?
So I did a copy with mates,
Yeah.
and it's allowing me. It's like, we'll do it again for these motor screws, and I'll go slower. So those are gonna 1032.
It's like a helpful tool.
Yeah, it's helpful if you're placing a bunch of the same parts. Okay, so I'm gonna copy with mates. So it's like, yeah, is that the component you want? Yes, it is. Alright, so it knows I did a coincident and then a concentric. So I still want to be, I'm going to do this one, so I want to be coincident to that surface, and concentric to this one. Yeah. Coincident, concentric. Let's get this hidden one.
So after you put one part in that is coincident and centric to a surface, then you just
Yeah, you can repeat it. And it's not always coincident and concentric, it's just whatever the thing you're copying has on it already. There we go. Okay. Let's put in our screws. This 2-inch one?
Is that gear as directly connected to the CIM motor is gonna stay on? Like that?
No, we need to put the retaining ring things on still. I don't know why, but I like to select the face, not the edge. Centric. Okay. So then this is actually, we're editing this part in context, and we're going to make these holes big enough so we can put the screw head, and we can put the screw in.
We should probably put a washer between the 2x1 and the screw head, right?
Just maybe. Just because the screw head's not very big.
Yeah. And this is a surface that we're mounting to, so we don't want it to wobble at all. So
That's true. I think it might be okay. Alright, so 2 1/4 is the next size up, so. Ooh, so close. Oh,
scoot it all the way.
got it. Oh. Okay, well, they stick out a little bit, but
Put a washer in there, they won't too much.
yeah, that's true. Seems annoying to get the washer in, I guess we make these holes bigger.
Yeah, to make those bigger, put like a slot on the top.
Okay, let's put on those retaining ring things. Where are those? Probably. Yep.
You're gonna put one of those on the front and the back?
That's right.
Okay. Could you have the gear just more towards the mini sim and then cut down the shaft just so it doesn't protrude so much?
I think our limiting factor is this is kind of close, but I guess this gear is extra long, so you could have it.
No, not necessarily that, but like just it sticks past the edge of the gear.
Yeah. I mean, you could.
Just make it as short as possible.
I don't know if it's worth it. I don't know if you want stuff that close to that anyways.
I mean, don't even move the big gears. Just move the pinions closer to the knee-sim,
Okay, yeah.
and then cut down the shaft on the knee-sim. But that might be a dangerous thing.
Okay. Jeez, what's going on here? That's way out there now. Yep. Okay. What happened to this screw?
I think you missed. I think you put it in the other side.
Oh. Put it in the hole for the spacer. Okay. Looks pretty good. Let's just make this aluminum colored.
Something you have to worry about is the spacer running into the chain. I mean, it looks like you
This-
spaced it properly, but...
Oh, these
but-
spacers?
Yeah.
In this stuff? Yeah, I think we're clear. That is something that
So yeah, and the motor's pretty close to it.
I think we're clear though. You can tell that we are, but it's definitely something you want to make sure pretty early in the process. I guess we should put in these screws. I think I predicted we would need those ones also. Let's see if this is gonna work. Yes. Oh, I don't know why they're not just strange. That looks okay. Looks like they don't quite fit perfectly. Okay. And then another thing that so I think we're pretty much done, but let's add some stuff to folders and clean this up here. So like sample parts. Let's put our wheel in there too. Got a lot of hardware.
Can you combine all of that to as like a one part?
All the hardware? I mean, I guess I don't think it's probably a good idea.
I mean, it's not good, but I'm just theoretically. Because there are times like where you should do that maybe.
Well, if it's all one part, it's all gonna like move together and
So like, if you want to, actually, never mind. That was not a good question.
let's put our motors in the folder, even though there's only 3 of them. Oh, bearings would be nice. Let's do gears. Spacers. Okay, so that's pretty decent. We made our assembly not as crazy. Then you can also do interesting things like just show the hardware or something like that.
Alright, 2 shots.
Okay, it looks pretty nice, I think. So yeah, so like what's not CADs on this? So yeah, the 3 shafts and the plates. So there's 5 custom parts and the rest is CADs. It's pretty nice. And those shafts were pretty easy to make on the lathe.
Alright.
Cool.